Hello students, in this course we will be talking about quantitative statistics. You have already started this course. Professor Sharda requested me to talk about the basics of quantitative statistics. We discussed part of it in the earlier course, and this is just a review of some of the basic stuff. Most of this stuff must you already know that, but some of you may have certain doubts, or you said that if a revision happens it will help. So here it is. By the way, these are I will take you through the initial steps when you put the data in your SPSS, and you want to do certain initial look at the data and some checks, etc. So I will show you how to do those. At the same time, I will also take this opportunity to actually briefly revise those concepts also. Descriptive statistics usually deals with things like mean, mode, median, standard deviation, etc. And in the data check phase, we check about whether the data is normally distributed, if there are any outliers. Sometimes outliers are due to the fact that either the observation is incorrectly recorded, or it's invalid due to some other reason, or there is an outlier with the observation valid, but it may require some qualitative assessment before you move further with quantitative assessment. So you need to check beforehand. And then further, you may need to do some transformations. Transformations could be simple things such as some variable is a very high number, 10,000, and the other is 500, which may not fit on the graph if you're plotting. So you may would like to transform the variable into a new number so that it fits the curve properly. You could do suppose a simple thing such as 10,000, 50,000, 100,000. So you can take base value as 10,000, and you can transform the data into 10,000 into 10, 50,000 into 50, hence and so forth. Or it could be log distribution. You can take a logarithmic function of all the values, and then you plot it on the graph. And then you do some correlation, and that is dealt with in inferential statistics. Statistics in general is a branch of mathematics that is used to transform basically the raw data into some meaningful information. And when we say meaningful information, it may have certain things like some calculations which could be of use to decision makers. And if we broadly classify statistics in your case, although there are this is a vast field, but for you what is relevant to know is two types: descriptive statistics, where we deal with basically summary of the data, describing the data in a manageable form, where you are not interested into doing some complex correlations and which factor is impacting what. You are just summarizing like the average of the entire thing. So those kind of things are in descriptive statistics. Inferential statistics, where you need to do some prediction based on some data. It could be some correlation stuff, it could be some regression, etc. So all these things are dealt with in inferential statistics. This is the things that you will be dealing with in descriptive statistics. You will be dealing with frequency distributions, stem and leaf plots, histograms. You will be dealing with the three aspects of data. First is central tendency. Central tendency is how the data is, the tendency of the data to converge into some area or a point. So that nature, to assess that nature, that is central tendency. Second is dispersion, how scattered the data is, uh, how spread out the data is. And the third thing is distribution. Distribution could be the how data is distributed in terms of how many of what kind. If you plot a distribution of the data, whether it's going towards the peak, or it's going flat, or it's going towards the left side, or it's going towards the right side. So such nature is studied in the distribution. In central tendency, the measures that we typically look at is mean, median, mode. In dispersion, we look at things like range, median, quartiles, percentiles, standard deviation, variance. In distribution, we look at things like skewness and kurtosis. We will go into details of these measures one by one. By the way, in SPSS, if you go to Analyze and your data window, if you go to Analyze and there's an option called Descriptive Statistics, and you go into Frequencies, Descriptives, and Explore, these three options basically give you these measures that we just saw. We will now go into one by one these measures. First, let's see a normal stem and leaf plot and frequencies. Frequency, as the name suggests, is the number of times a particular data item is there. For example, if the frequency says 3, that means that a particular data is coming 3 times. Then there's stem and leaf plot. Stem and leaf plot, see this example here. The numbers are 15, 16, 21, 23 through 32, 41. If you see the stem and leaf plot, you see the number 32 is placed in the line 3 and 2, and there's a number 30, so 3 is 0. So imagine here the number in the tens place is acting as a stem, and you see, so this gives you some kind of that how many leaves are there in a particular stem. So in this case above, you see that how 32 and 30 is placed. In the example below, there are 10 cases, and number of stems are 10, that's stem width, and each leaf is 1. Then there are histograms. Histograms are basically frequency, the parameter, and the frequency of that particular parameter. For example, the graph in front of you is student age, and how many students have that age. So that is the plot of that kind of data. This gives us a rough idea about how an overall data looks like. I am again help you recall that descriptive statistics is all about getting a snapshot of kind of data and the summary view. What's the nature of the data? We are not interested in going into details of what means what. Those kind of analysis, that why and what leads to what, those kind of things comes in inferential statistics. So here descriptive statistics, we do this. And which chart is relevant for what kind of description, that totally depends on the particular case. So it's not that you will require all of them at one go. So you need to apply that wisdom that which graph or plot or representation would be used for what kind of description. This is the most popular measures in descriptive statistics, which tells about the central tendency of data. I just mentioned central tendency is the tendency of the data to converge at one point or an area. Mean is just sum of the numbers divided by the number of data. In the given example, you can see the mean is 7. Median, sometimes there are data points which are way too away from the rest of the data numbers. To give you an example, let's see salary of the salary of various MBA graduates coming out of the university. Suppose one person gets a pay package of 200,000 euros, and rest of them they got 80,000 euros, 90,000 euros, 82, 85. If you take a mean, then this one outlier, 200,000, will significantly impact the position of the mean. So it will not give the right view of the tendency of the data. Suppose if mean comes to be around 120,000, so most of the data is not around 120,000. Data is around 80,000. But why you got 120,000? Because there was an outlier which was at 200,000. So when we take median is the middle number of a sequence, or in other words, it's if you arrange the sequence from increasing to from the lowest to the highest, is the middle number. Sometimes if you have an even number of numbers, then the median would be the average of the middle two numbers. And in this example, 3, 5, 5, 6, 8, 10, 12, the median is clearly, since it's an odd number of data points, so the median will be the middle number, that's 6. Then mode is the number that occurs most often. In this example, you see that 5 occurs twice and rest of the number occurs once. So the number that occurs the most is 5. So mode is 5. In SPSS, you go to analyze descriptive statistics, go to descriptives, and it gives you the option to see sum, mean, median, mode as part of the measures under central tendency. You can try out this stuff after the presentation, and in case you have any problems, you can ask the instructor. Then how spread out the data is. That means how far is it from the median. The word percentile, quartile are basically the measures that are used here. When we say 75th percentile, that means 75% of the data. Some part of data which is 25% from the central median. If you plot the distribution and if you take exactly half, the half median point is treated as 50th percentile, and then you break it down into quartiles. That means the whole distribution will be divided into 4 equal parts as shown, and accordingly you can see what it means to be 100th percentile, 75th percentile. And there is something called an interquartile range that tells you about the exact spread. An interquartile range is basically the difference between two quartiles. Q3 minus Q1 is the spread of the data, and the measure that is and this measure is known as interquartile range. And if you go to the same, as I told you, all the descriptive statistics options are there under analyze descriptive statistics, and you go to descriptives and you see the options for percentile also, quartiles, percentiles. This is another measure for dispersion. This is called standard deviation and variance. Standard deviation is a measure of how far the data is from the mean, and variance is a measure of how the data vary as we move away from the mean. You don't have to go into the mathematical values, mathematical formula of how to find variance and standard deviation, since most of the time you'll be working with the SPSS or any other statistical software to find out. But I wanted to just bring your attention to this, the underlying meaning of this measure. This meaning of this measure is important because when you see the data and you are looking for some measure to describe the data, so given your situation and a problem, you should have the wisdom to pick the right measure, so that you will be able to pick if you know some basics like this, the standard deviation, variances in relation to the mean. Range is maximum minus minimum. Pretty simple. This is just an example of how do you arrive at the standard deviation, but I don't think so you would like to calculate it. Your statistical software do it for you, but this is how it works. You take the data, you find out its mean. In this case the mean is 87.85, and you subtract each of the data points from the mean to find out how far is it from the mean, and you get some value. You make it squared, and then you again sum it up and you find out that mean, and that's your variance. And if you take the square root of it, you get standard deviation. These are the options that are there in SPSS, and this is how SPSS shows standard deviation. Now let's see another interesting descriptive category is distribution. Distribution is basically how the distribution looks like. Is it more towards the left or the right, or centrally distributed like a normal distribution, or it is going towards the peak or flat. The degree of symmetry, that how symmetric the distribution is, this measure is called skewness. And the degree of how high or peak the distribution is, or how flat, that measure is called kurtosis. If the skewness is less than 0, then you can infer that it's skewed to the left, and if you see 0, that means normal distributed. If your skewness is positive, then it's a right hand skewed distribution. Kurtosis is if it's flat, and the term that is used to describe flatness is in the distribution is called Platy-Kurtic distribution, with value of kurtosis less than 3. That means the peakedness is less. Kurtosis is basically a measure of peakedness. So if you see a higher value, that means the peak is high. If you see a lower value, peak is low. So you have 3 types of kurtosis: platykurtic, mesokurtic. Mesokurtic is normally distributed. Leptokurtic. By the way, mesokurtic means normally peak. Leptokurtic, high peak. Now let's see how do we check normality, and what does that mean, and why do we check that? Most of the time when you will apply complex statistics from here on your data, a lot of those formulas have assumption that they assume that your data distribution is normally distributed. So if you apply those algorithms or those formula of complex statistics which assume normally distributed data, and your data is not normally distributed, then you will get very erroneous results. So that's why this is very crucial step where you check whether that population is normally distributed or not. At this stage also you will see whether are there any outliers. Outliers are those observation points which are distant from other observation. For example, if you are measuring the height and the values are 6 feet, 6.5 feet, 5.5 feet and 12 feet. Now the height can't be 12 feet. So but when you are looking at the data for this kind of an analysis, then you will figure out, oh, the 12 feet height, it's not possible. Maybe you have done done some error in writing, or the instrument with which the height was measured had some problem. So these kind of things are called experimental error. And sometimes there is a genuine outlier. So you would like to qualitatively look into it, before you move further. For example, if you are studying the salary distribution in MBA school, and one of them got some a very high paying job, maybe $1 million from some investment bank due to some reason, and you are doing this analysis of median salary because you need to you need to put this in your annual report, which will be read by your stakeholders to get an idea how the school is doing and how the students are performing. If we add that 1 million outlier and when use mean as a measure, then this outlier will significantly change the representation of the data, and which is undesirable. And this is one example, and there could be example wherein this outlier is the thing that you would like to investigate further qualitatively. So these are the 2-3 scenarios that this kind of data check for outliers help us in figuring those scenarios out. You go to descriptive statistics, explore, and then you get an option for doing check for normality with plots with tests, and these are the reports. If you see the level of significance, and then you can infer that they are not normal. For example, the data that is shown on the graph right now is a normal distribution, which is around the line, almost more or less around the line. Please note that these tests here, the significance, if it's low meaning less than 0.05, that means that the data is not normal. Sometimes students do this mistake. They take it as that it's normally distributed if the significance level is okay. So, but it's the other way around, because these tests are based on the hypothesis that data is not normal. So the significance level is for that hypothesis and not for the hypothesis that the data is normal. This is for outliers, and this is a normal outlier thing. You see as a sample where it's showing the military expenditure as percentage of GDP, and you see some outliers like Croatia, Oman, Saudi Arabia, Kuwait, Jordan, Israel, and Syrian Arab Republic. It's outside the box plot, and it's shown in these circle, star, and these legend tells us how away they are from the rest of the data. And these are the percentile range. If you remember, I showed you on the graph in few slides before, how do we see the percentiles? An interquartile range is the third percentile minus the first percentile, Q3 minus Q1, and it's shown here 3.3 minus 1.2, that's IQR, interquartile range. And this is the transformation in your data editor, where there's an option called compute variable. You can add new variable and you can give it a numeric expression. I am giving the same example again. Suppose your data is 10,000, 20,000, 30,000, 40,000, 50,000. You see that there is always a thousand. You don't want to plot a big graph, so you basically divide every data by 1,000. This is a simple case. There could be a case where data is very large and very spread out. In that case, you would like to take a logarithmic of that number. So this is called log transformation. And there are other kind of transformations too, and you can use your own formula and calculations. So this screen allows you to do that. I hope this basic recap, it was pretty basic, but I hope it serves its purpose, because sometimes you make very basic mistakes in choosing the right measure for right kind of description. I hope with this it will help you pick up the right measure from descriptive statistic to describe your data in the most effective way. Thank you.